We use one pair of alternate interior angles. Careful, 5 and 2 are vertical angles. They are not alternate interior angles. Trey? 2 and 7 are alternate interior. Angles 2 and angle 7. So Gavin, remember, alternate interior are on the same side of, or excuse me, opposite sides of the transversal, but they're interior, meaning they're in between the two lines. So all of these 4 angles are considered interior angles. These 4 are considered exterior angles. Does that make sense? Okay. What would be another pair? Math. 3 and 6. And those are the only alternate interior angles in the picture. Any questions about that? We're going to be using the idea of alternate interior angles today, so it's important that you understand those. All right, use your calculator to type in tangent 30 to the nearest hundredth. What did you get? Point what? 58. All right, 0.58. Does everybody agree with that? Remember that you should be able to find the exact value of the tangent of 30. That was on the homework assignment that you turned in last time. Let's review that real quick. If I want to find the tangent of 30 without my calculator, what do I do? Draw a triangle. What kind of triangle? Okay, and more specifically, what kind of right triangle? 30, 60, 90. Okay, let's label our rule for that. What's across from the 30? Not 2s. L. What's across from the 60? L square roots of 3. What's across from the 90? 2L. We're still stumbling on that. By next Wednesday, you have to know that. So if I want to find the tangent, which 2 sides do I use? Opposite and adjacent. So the tangent of 30 is equal to the opposite over the adjacent. If I'm looking at the 30-degree angle, which side's the opposite? L. Which side's the adjacent? L square roots of 3. Make sure you're watching up here because some of you did not get this on the homework assignment. The opposite is L. The adjacent is L square roots of 3. What do we do from there? Take out what, Tate? Take out L, cancel out the L's, so the L's cancel. What are we left with? Not square root of 3. What are we left with? 1 over the square root of 3. Remember that this square root of 3 can't magically jump up here to the numerator. It is in the denominator. So there has to be something up here, and that's the number that was in front of your L. The number in front of any variable is always a 1 if there's not another number there. Okay, and then if you have a square root of 3 in the denominator, are you allowed to leave your answer like this? No, so what do we do? Good, multiply by square root of 3 over the square root of 3. Multiply straight across. What's 1 times the square root of 3? Say it again. 1 square root of 3, or just square root of 3. And what's square root of 3 times square root of 3? Square root of 9, which is 3. So I'm going to ask you on the test to be able to find the sine, the cosine, or the tangent of any of our special angles, 30, 60, or 45 degrees, without a calculator. And again, I'll know whether or not you used your calculator because this looks completely different than 0.58, and your calculator cannot change a decimal back to a radical. So you'll be stuck if you try to use your calculator. Okay? Questions? All right, so this just said use your calculator. If it says use your calculator, you can use your calculator. All right, if we want to solve for the tangent of 54 equals 2500 over x, what do we do? Okay, put tangent 54 over 1, make a proportion, and then cross multiply. So we have x times the tangent of 54 equals what? 2500. What do we do then to solve for x? Okay, and you can divide by trig functions as long as there's an angle with it. So tangent of 54 is what we divide by. The tangents cancel, and we typed this into our calculator, and we rounded to the nearest hundredth. And what did you get? I'm sorry, one more time. 3.77? Okay, double check that again, Gavin. 2,500 divided by tangent 54. Okay, 1,000 816.36. And were there any units in this one? No, there was not. Did you get it that time?
Yeah.
Okay. Okay. Yeah, so be very, very careful. Any questions? So that is only when you're finding angles, okay? So if you're dealing with a triangle and you don't know what the angle is, but you know the two sides, you're trying to get the angle by itself. And you'll know, Brock, because your variable will be where the angle measure goes. So if you're trying to get rid of just the tangent, you can't divide by it, so you do the inverse. That. Uh-huh. You have x times the tangent of 54, which is what we had here. And then 1 times 2,500, which is 2,500. And then to get x by itself, you divide by the tangent of 54. Because this is x times the tangent. The opposite of multiplication is division. Does that make sense? Yes. So what Peyton just asked is, wasn't there a trick in the video? There was a trick in the video that said when x is in the denominator, you can just simply switch the trig function. So you can definitely use that trick. It works every time, or you can just put it over 1 and cross multiply. Thad, you okay? Okay. All right, so we're going to move on with just the new concept, angles of elevation, angles of depression. When you think of depression, what do you think of? Sad? Okay, oh, that's not good. So if you're depressed, would you be up or would you be down? Down. So when you think of an angle of depression, that means you're going down. When you think of elevating, what do you think of? Going up, even though elevators go up and down. But we're going to think of elevating something as rising it up. Depression is going down. Now here's the key, and I'm going to warn you, this is where most students mess up. When we talk about elevation and depression, this is going from the horizontal. This is very, very important because most students who make this, who do it wrong, go from the vertical. It has to be from the horizontal up or from the horizontal down. So on your notes, when you look at the definitions for angle of elevation and angles of depression, angle of elevation is the angle formed by a horizontal line and your line of sight. So horizontal line and your line of sight, if it's angle of elevation, it's to a point above the line. So in other words, I'll draw up here on the board. If I have a horizontal line and I'm going up with my line of sight, so I'm looking up at something, this is an angle of elevation. Does that make sense? If I am looking down at an object so that my line goes down from the horizontal, then that's an angle of depression. But it's from the horizontal. If you go up from the horizontal, it's elevation. If you go down from the horizontal, it's depression. Not from the vertical. So be very, very careful. So when you look at this picture, we're talking about from the imaginary horizontal line. Most of the time, that's not going to be drawn in your picture, and you're going to have to think, where's my imaginary horizontal line? So that's your line of sight, where you're looking. If this is my horizontal and I'm going down, that's an angle of depression. If this is my horizontal line and I'm going up from the horizontal, that's an angle of elevation. So just think about your horizontal. Is your angle formed by going up, or is your angle formed by going down? Elevation's up, depression's down. Questions? All right, so angle of depression is formed by a horizontal and the line of sight below the line. So the first kind of questions on your notes are just simply going to be asking you to identify whether or not they are angles of elevation or angles of depression. But before you skip to that next example, look right here. What do you notice about these two parallel lines and this line right here and these two angles based off the bell work? Their alternate interior. So every angle of elevation is going to be congruent to its corresponding angle of depression. So if your problem gives you information about an angle of elevation, but what you really need is the corresponding angle of depression, you just know they're going to be the same. Does that make sense? Okay, so I'll show you in some problems later. But here's your first kind of problem. Classify each angle as an angle of elevation or an angle of depression. So when you look at angle 1, every time you're going from the horizontal. So to make angle 1 from the horizontal, do we go up or do we go down? Down. So this is an angle of depression. Make sure you put angle of, and don't just write the word depression. Depression is different than an angle of depression. So make sure that you put angle of, or at least do angle of, and then depression. Okay? So angle of depression. Look at the next one, angle 4. Are you going up from the horizontal or down from the horizontal? Up. And again, find your horizontal line and then ask yourself, how do you make the angle? You go up from the angle. So that's an angle of elevation. All right, you and your partner try the next two. Figure out what are angles 5 and 6. All right, Corbin, angle 5, elevation or depression? Angle of depression. Again, if you're looking at that and you're not sure, draw your horizontal line and then draw the other line that makes the angle. Did you go down from the horizontal or did you go up from the horizontal? And you went down. So this is an angle of depression. All right, angle 6, Michael, angle of elevation or angle of depression? Again, now you're looking at this horizontal and this line, and you have to go up from the horizontal to make angle 6, so that is an angle of elevation. Any questions about the difference between the two? Okay, so like I said, that's really the only new information today, and now it's just going to be applying those to some word problems. The hardest part is going to be drawing your picture correctly and then being able to use your trig from the picture. But oftentimes you're not going to have a picture. So I'm going to ask you to pretend that this picture's not here. And in fact, I think I took it off of your notes, right? Because you're going to have to be able to read this word problem and develop your own picture. But here's some advice. What has this whole chapter been about? What kind of triangles? Right triangles. So ultimately, what do you think your picture should turn out looking like? Right triangle. Could be a square that's divided into two right triangles, okay? But it's going to be a right triangle. So if you're kind of having trouble, then draw yourself a right triangle and see if you can then put in the information that's in the picture if you get stuck, okay? But start by reading and then visualize in your mind, what is this looking like? So you've got a Space Needle casting a 67-meter shadow. First of all, where are shadows located? Are they up in the air? They're on the ground. Be very careful with that. So you have a shadow that should be on the ground. And how long is the shadow? 67 meters. So always think about, where is this located? The biggest one I usually see students make a mistake with is a leaning ladder. If they say there's a ladder leaning against a building, can the ladder be vertical? Not if it's leaning against the building. Is the ladder on the ground? No, it's leaning against the building. So the hypotenuse would be your ladder. But oftentimes I'll see students label the vertical line as their ladder or the horizontal line as their ladder. Or maybe it's a slide. You're at a playground. You've got a picture of a slide. Is the slide vertical? No, and the slide's not on the ground. The slide is your hypotenuse. So try to visualize what should these pictures look like. All right, so Space Needle casts a 67-meter shadow. If the angle of elevation, angles of elevation go from where, what direction? They go up from what? From the horizontal. So it's always from the horizontal. So from your horizontal, you're going to go up to make your angle of elevation. So you have an angle of elevation. The angle of elevation from the tip of the shadow to the top of the Space Needle is 70 degrees. So this angle right here is 70 degrees. How tall is the Space Needle? So somewhere up here we have our Space Needle, and we want to figure out what's the height of the Space Needle. When you measure the height of something, you should always be measuring it so that it is perpendicular. You don't lean over and then measure your height, right? You stand straight up and tall and measure your height. So your Space Needle should be perpendicular to the ground here. Does that make sense? So are we looking for the hypotenuse or this other leg? The leg, the height. What's the height of that Space Needle? Once you get your picture drawn, this is just what we've been doing. We're using SOHCAHTOA. So which two sides do we have here in our picture? Opposite and adjacent. Which one's the opposite? X. And this is the adjacent. So we go back to SOHCAHTOA. Which trig function uses opposite and adjacent? Tangent. So now we have tangent of what angle? 70 degrees equals what over what? So x over 67. Now, again, if you're getting confused about when do I use tangent, when do I use inverse tangent, are we looking for an angle here? No, we are given the angle, so we are not using inverses. We are just solving for x. So we can do exactly what Tate reminded us of this morning. Put this over 1, cross multiply. Or the trick in the video is, if x is up high, you just multiply the two things. However you want to think about it. Cross multiplying gives me x equals 67 times the tangent of 70 degrees. And then you type that into your calculator and round according to your directions. What does it mean to round to the nearest meter? Nearest whole number. So what is this approximately to the nearest whole number? 184. And my units? Meters. How do I know when my units are going to be degrees? When you're looking for an angle. If we're not looking for an angle, it's not in degrees. Questions? All right. Look at the next one. Oops. And see if you can do this one on your own with your partner, and then we'll check it. Bless you. When you think you have an answer, let me know. I'm coming around to check. Or if you're stuck, let me know. Okay, so suppose the plane is at an altitude of 3,500 feet. Where would that go? Where? Well, your plane is up here, so what part of your triangle would be 3,500 feet? altitude is the height of something. Perfect. The picture looks really good, except it was at 29 degrees. So you're really close. Awesome. Good job. Amazing. You're doing great. Keep going. Your picture looks great. Your picture looks great. Keep going. So, first of all, I would ask you, you make it in the picture, your picture makes it look like your airplane is down here below ground level. But really, your airplane is up here, right? Okay, so I'm going to look at it this way. So your airplane's up here, and it says that the angle of elevation from the airport to the plane, an angle of elevation does not go from the vertical, it goes from the horizontal. So if I'm going from here up, then this is the angle that should be 29 degrees. Does that make sense? Okay. Okay. Altitude. What does altitude mean? Okay, so back in chapter 5 we talked about altitude. Altitudes go from the vertex perpendicular to the opposite side. Altitude is another word for height. So what's the height of your triangle? Right. Good. Yes, but it wouldn't be this angle that would be 29. It would be the angle from the horizontal down that's 29, which then is alternate interior to this angle. I don't know if that makes sense. Okay. You still have the 3500 down here on the bottom. Where's the 3500 supposed to be? And why is your right angle up here? No, I said the altitude is 3,500 feet, and you have your altitude in the wrong spot, not your angle. No. Altitude is height. If an airplane is up here in the air, the altitude is the height of your airplane. Right. Okay, we're going to go over this one, but what I'm noticing is a lot of you are having trouble with the word altitude. Altitude goes back to chapter 5. Chapter 5, we talked about medians, altitudes, perpendicular bisectors, and angle bisectors. So you may need to go back to chapter 5 and study up on altitudes. But what is another word for altitude? Height. Your altitude is your height. When they say the altitude of an airplane, they're talking about how high is the airplane from the ground. How do you measure the height of something? Do you measure it diagonally? Straight, perpendicular, up and down. So when they say that you have a plane in the air, hopefully, and then you have an airport, which is hopefully on the ground, it says suppose the plane is at an altitude of 3,500 feet. So your plane has an altitude, meaning perpendicular to the ground. Its height is 3,500 feet. Then it says that the angle of elevation from the airport to the plane. Remember, angles of elevation go from where? From the horizontal. I'm going to keep saying that because that's where I see mistakes. So you have to draw in this horizontal line to your airport. The angle of elevation goes up from the horizontal. So up from the horizontal, this angle is now 29 degrees. Getting your picture drawn correctly is the hardest part. Once your picture's drawn, then you're just trying to answer the question using SOHCAHTOA. What is the horizontal distance? So is that the hypotenuse or is that this missing leg? The missing leg, horizontal. So what trig function uses these two sides? Tangent, because this 3,500 is now the opposite, and this x is now the adjacent. So we have the tangent of what angle? 29 degrees equals 3,500 opposite over adjacent x. Put your tangent of 29 over 1 and cross multiply. so that you have x times the tangent of 29 equals 3,500. And then divide by the tangent of 29. Be careful that you are rounding appropriate to the directions. It says round to the nearest foot, which means the nearest whole number. So what is this to the nearest whole number? 6,314, and what are your units? Feet. Questions? Okay, try one more. This is probably the hardest one. This is the last one we're going to do. We're not going to do the hardest. The last two are the hardest, but we're not doing those. So of the ones for today, this is probably the hardest. Try seeing if you can figure out this one. Okay, and then when you think you have an answer, I'll come around and check it. Again, talk it out with your partner or the people in front or behind you if you're having trouble. That's perfect. Good job. Please look up here so that you can see how to work this problem. Again, I think you would probably agree the hardest part here is getting your picture correct. If I give you a picture, I think a lot of you are doing really well with SOHCAHTOA. But getting your picture correct. I'm going to draw it the way I saw most of you drawing your picture, which is probably a little different than how they drew it up here. An ice climber is standing at the edge of a crevice. What's a crevice? Like a hole, okay? So we've got this divide in the ground, like a hole in the ground. So he's standing up here at the top, and the crevice is 115 feet wide. So I saw a lot of you put your 115 feet down here at the bottom for the width, and then you drew your triangle going straight down from the ice climber, making a 90-degree angle. It says the angle of depression from the edge where she stands to the bottom of the opposite side is 52 degrees. I saw a lot of you put this angle of depression in the right place for the problem, but you didn't show me how you got that. The way you should have shown it, and I didn't see anybody do this. So if you would look up here real quick. An angle of depression goes from the horizontal down. But nobody drew that. Most of you just put your angle down here. That's not an angle of depression. What is this angle right here? Angle of elevation. But we did talk about an angle of depression is always going to be equal to its corresponding angle of elevation. But what really, in your picture, this should have been labeled 52 degrees. And then because you have alternate interior angles, that makes this 52 degrees. Does that make sense? Okay, let me come back to you in just a second, Thad, because I'm going to work this the way I saw most of the people drawing their picture, and then I'll come back to the way you drew yours, okay? So first of all, the other thing I'm seeing is some of you are putting your X in the wrong place. How do you measure depth or height? How deep something is or how high something is? Always perpendicular. So the height or the depth is always going to be your perpendicular side. At that point, you have opposite and you have adjacent, which means you should be using tangent. So the tangent of 52 is equal to the opposite x over the adjacent 115. Put it over 1, cross multiply, and you multiply 115 times the tangent of 52, and you round to the nearest foot. And what did you end up with? Oops. 147. So 147 feet. Okay, I'm going to come around and give blue slips, but before I do, and I'll look at yours, Thad, when I do. Anybody have a question about how we set this up here? Okay, so if you didn't get a blue slip, I'm coming around. I'm going to give you one. You have 2 things to be working on. Top priority is this homework assignment. You've got the rest of class time, which is about 45 minutes. Then if you get that finished this weekend, you're focusing on the review. Trying to go ahead and get your review going so that we can play a review game this next week. I'll come right back to you, Thad. I'll grab those staplers from you guys. But homework's top priority. Homework is due, finished on Monday. The review is not for a grade, it's just to help you study. Did I miss anybody with the blue slip? Okay. Okay, sorry, Thad. Okay, so I follow that this is 115 and this is 52, and that would be fine. But I don't see where your work is. All I see is an answer that you plugged into your calculator to get this, but where did this come from? Because your picture's fine. So start with your trig function. Tangent of what equals what? So now what do you do to solve that? But it's not on the bottom, right? So you should have put that over 1 and cross multiplied. So don't try to skip this step, because then you're going to end up messing up on this step. But your picture was totally fine. You can draw it that way, no problem. Okay? And if there